Hello, welcome to another stream about that. Welcome. So today is Sunday, if I'm not mistaken. I think today is Sunday, and that means today, according to the schedule, we're supposed to be doing game development, but I started a very strange topic that I cannot finish. So yeah, we're gonna continue doing the 3D graphics in OpenGL. Today I want to actually fix the problem with the distorted textures. We'll see how it will go. It's apparently a very hard problem to fix. You can find the source code there, and let's take a look at it. I absolutely hate this project, but I cannot stop working on it until I actually get it working. Hello everyone, hello Odd9, UT61, Pari, Yatanasov, Honeymize, Cerimon, MCourse94, Belginal, Binary Stream, Catison, Shigiman, hello, welcome. So, let me fetch the latest stuff. So I think I already have the latest stuff fetched, and so today we need to fix this problem. So I tried a lot of hypotheses, I read a lot of tutorials, majority of them were trash. So I think I need to finally try another thing, and essentially try to not do transformations in the shader, because I have a suspicion that that could be due to me doing transformations in the shader. So what I'm going to try to do, I'm going to try to do all of the transformations on the CPU, at least prepare the matrix on the CPU, right? Just prepare the matrix on the CPU and just send that matrix to the shader, and including also projection. We're going to try to come up with a projection matrix on the CPU, and yeah, just multiply with it, and we'll see how it goes. At least that's the plan for today. I'm not sure if it's going to work or not, but hopefully that will give us some clues on why the fuck we're getting this kind of shit. Alright, so that's the plan for today. That's the plan for today. Okay, so I think we need to comment. Title. Do we have a title? Okay, at CMD title times people were debated by the title. We already have the first one. There we go. One people were debated by the title. So every time somebody's gonna tell me that the plural of matrix is matrices, just issue this command. So, and we'll see how many people will be able to get. So this is basically the streaming 101, right? So you want to attract people, you just like do this kind of clickbaits, like you put small little things into the titles or thumbnails, and there's certain kind of people that cannot resist to comment on these kind of things, and we're trying to basically trigger these kind of people. So matrices, yes, exactly. Matrices. I'm a grammar Nazi by nature. This is unfair. Oh, you deserve it. You 100% deserve it. I'm telling you that. So, let's see. So I'm gonna start with actually maybe enhancing our our matrix library, I think. Our matrix library. Yeah, we do not approve of Nazis, by the way, on this Christian Minecraft server. By the way, so we have like 4 components in here, right? So we have 4 components in here, and this is gonna be comps. And another thing I would like to do, I would like to maybe rename this matrix into mat4, right? Because usually in the in the OpenGL, they're called mat4, and in the how is that called? In the context of computer graphics, usually we use 4x4 matrices anyway, so it just doesn't really matter. So it's better to just call it mat4, and this is gonna be mat4. This one is gonna be something like Emacs. Mat4 rotate, right? It's gonna be rotate. So I need to adjust my keyboard a little bit. Right, so what are the other things we'll need to have? I think we'll need to have something like mat4 translate, right? Translate. So float y, float z. So yeah, so that generates the translate matrix, and we'll see how it goes. So we need to implement this thing as well. Mat 4x4, mat4, and let's see what's gonna happen. Okay. Oh yeah, I also have to rename this kind of stuff. Rotate. Rotation. It's not a particularly good name. Rotate and rotation. I need more team. how do you construct the translate matrix? How do you construct the translate matrix? So let's find out. Let's find out. And here it is. So VS. So essentially, all right, we basically want to add x to the x component of the vector, right? To the x component of the vector. And so that means we need to take the x, we don't need to take y and z, right? And we need to add x to the x, so this is basically the first thing. And then we're gonna take the y coordinate, and this is gonna be y, and then we have to take the z coordinate, and there we go. And I suppose here we're just gonna do that, and that's it. So I suppose this is the translation matrix, right? So basically it takes all of the coordinates, right? It takes all the coordinates, and to x and y and z it just adds these particular values. I guess that's how you do the translation. So we also can do rotation, but rotation we already coded it, so we don't have to do anything special in here. Do we need anything else in here? We probably need scaling, right? We probably need another matrix for scaling. So how do you do the scale? It's gonna probably have a similar signature, right? Because you can scale by x, y, and z, right? So why not? But it's gonna be slightly different, I suppose. It's gonna be slightly different. So instead of using like ones in here, we're gonna put x's and y's in here, so which will essentially multiply the corresponding components by those specific values, and this thing has to be just that. There we go. All right, so I hope that's gonna work for now. We'll see if I did any major fucky-wacky, but I'm pretty sure that's how you translate or how you scale vectors, right? So I think that's a pretty good scale matrix. So this is the translation matrix, and this one is the scale matrix. So alrighty. Yeah, so let me try to compile this entire stuff. So I have some weird shit which indicates that I forgot to save my files. Don't forget to save your files. Imagine not forgetting to rebuild your project, but forgetting to save a file. Imagine that. Luckily, by the way, there's a pretty cool thing in Emacs. If you try to run something in the compilation mode, it doesn't allow you to run that in the compilation mode unless you have all of the buffer saves. So yeah, if you're not being a snob and actually learn useful features of Emacs, you can actually succeed in game industry and not forget to save files, because if you try to compile something from the Emacs, it won't allow you to not succeed in the game industry. It's just like there is a game failure prevention built into Emacs. It's actually a very useful feature, in my opinion. So now, not everybody knows it, because not everybody uses Emacs, but it's those people's fault for not using Emacs, I think. Now everything looks okay. So what's going to be the next thing we need to do? We need to be able to multiply vector and matrix, right? So we have a matrix that encodes the transformations on the vector that we want to perform, I suppose, right? And we want to apply that specific transformation to the vector. So let's actually do something like mat4 mult, or should I call it dot? I guess maybe it's better to call it dot. v4 Emacs best max. Yeah, Emacs is the best Emacs because it's not the text editor. I cannot say that Emacs is the best text editor because it is not a text editor, right? So that's why I'm saying that Emacs is a best Emacs. Some people would say that Emacs is an operating system, but nobody knows what is an operating system anyway, so it doesn't really mean anything. And it puts temporary files for unsaved files, so if you compile outside of Emacs, compiler gives errors for temporary files. It's if only you include temporary files into your build. But the question is, why the fuck do you include temporary files in your build? Like, why would you do that? So yeah, it's gonna be 4. It's gonna be mat4, it's gonna be a matrix, and v4, this is gonna be a vect. Alrighty, so let me just go ahead and implement this entire shit. Dot and mul are 2 concepts. Really? I thought it's 3 concepts. Interesting. That is very interesting. So... So what we need to do, we need to go ahead and just iterate rows. Look for components, so this is going to be components, and then we're going to be iterating the columns, right? Yeah, that makes sense. We're going to be iterating the columns. v4 components plus columns. There we go. So here it is. We'll probably need to have a result prepared, right? Met, I think it's VS. So iterating by rows. Yeah, and essentially we need to take the column and then multiply it by the vector column in here and just add it to the result. This is the components. I think like this, but maybe not. Maybe it has to be something like a row. Yeah, that makes sense. So here's the row, and for that specific row we iterate in the columns, and yeah, we're filling up all of the elements of the vector, and there we go. This is how we multiply the matrix and vector. So I think I'm gonna call it multiply, because I want to say multiply, so it's a little bit easier for my brain to actually work with this kind of thing. So it's going to be multiplication. Okay, so this is how we multiply matrix 4x4 with a 4-dimensional vector. Makes sense? Makes sense? Hopefully that makes sense. All right, let's try to compile this entire shit. Let's try to compile it. Okay. Another thing, we'll probably need to have a way to multiply 2 matrices. 2 matrices? Yes, we need a way to multiply 2 matrices. So, that's the right name. I thought it's a left name. I have so many discoveries today. Apparently it's 2 concept and not 3. And apparently it's a right name, not the left one. Amazing. Mat4 multiply mat4. Okay, so we're gonna have something like m1 and m2. So mat4. Why are you doing that to me? Why? I mean, if we were on Chatterbait, it would be nice, but we are on Twitch. Gotcha Hyper though, thank you so much. Yeah, but unfortunately I have to ban you. I'm sorry. And we're also gonna put the followers mode on 1 hour. Thanks for the cock though. So I'm gonna spam Gotcha Hyper a little bit so it cleans up everything. So it's actually... Yeah. So I suppose it's not visible anymore. Yeah. Yeah. Thank you so much. I do like what I see. Okay. Let's continue. Let's continue. So, what's gonna be the next thing? What's gonna be the next thing? Multiplication of two matrices, right? Multiplication of two matrices. So this is gonna be that step. Yeah. Don't forget about recommend. It's not that particularly. Some of the things with bra don't work, but yeah. Okay, so how do you multiply the matrices? Does anyone remember? So let's do it like this. So this is going to be the result, and we're going to return the result. Just a second, by the way, I need to double check something. Alright, okay, everything seems to be okay. Math, yeah. That's how I remember a temporary variable in the mult matrix. Do you really need a temporary variable? Programming has nothing to do with math for heads. Yes. Has nothing to do with math for sure. For sure, for sure. So there we go. Okay, so we're starting iterating rows, right, and columns. And within each rows and columns, we also have like oh yeah, that's what you're talking about. You're talking about temporary variable as the yeah, I see what you mean. It's more of like a third dimension, right? Because the naive way of multiplying matrices is cube, as far as I know, right? You can try to optimize that, but it's never been proven that there is like a square way of multiplying them. And yeah, even with parallelization, you just can't really achieve the square one. Yeah, you guys keep acting like math and programming are well-defined terms. Like, keep doing your thing, sure. And keep arguing about whether math is programming or not programming. You can also try to argue about whether the cereal is a soup or a salad. Yeah, that's another very interesting argument that you can have. It's literally the same level of bullshit. Seriously. So let me see. So this is gonna be a result, and the result is gonna probably refer to row and column. So, and what we're doing here, we're adding, right, so M1, so it has to be something like VS. So this is the row, and then we iterate in the column, and then we take the second one, and this is going to be the column. Yeah, we're iterating quickly rows, but we keep the columns like that. So this is roughly what we're doing. But yeah, I think this is the multiplication that we need here. I think this is the multiplication. Did I make any mistake in the multiplication? Can anyone tell me? Feng-Chi, thank you.
People who put milk first in cereal ESDF.
Thank you so much for 21 months of tier 1 subscription. Thank you. And welcome to our epic cock club. Welcome. How are you doing? So, yeah. Yep, cock. I think I didn't make any mistakes. All right, so everything seems to be okay. Everything seems to be okay. No, it doesn't compile because I forgot to return something. Has no. Yeah, this one has to be just mat4 then. This has to be just mat4. So what I want to do, I want to actually kind of remove all of the logic from the shader in here and basically make it as simple as possible. As simple as possible. So we're gonna just remove all of this shit completely because all of that will be done on CPU, hopefully, from now on. So yeah, the only thing we're gonna try to keep here is that one. Yeah, so this is gonna be just the position, and there we go. So it's gonna be vertex position, right? Vertex position. Yeah, it's pretty cool. Should be pretty straightforward. But it's not gonna work anymore. So let me try to recompile everything. Let me actually make sure that everything has been recompiled accordingly. Yeah, let's see. Yeah, it seems to be working. As you can see, it just actually shows something, but it's half of the screen. Right, the reason why it's half of the screen is because we're generating from 0 to 1. Right, so it's a 0, 1, 0, 1, 0, 1. So yeah, that's why it's half. So the first thing you need to do is actually shift it by minus half. By minus half, that's what you need to do, essentially. Now, yeah, to do that, we're going to use a translation matrix. Right? We're going to use a translation matrix. So where do we generate the mesh? The mesh. You have to use dollar, by the way. So let's actually have several matrices. I think it would be useful. It's going to be mat4, matrixes. We're going to say matrixes. Right, and I'm going to put some translation matrix in here. So it's going to be, well, you know what? Let's actually put like mat ID for now, I think. No, let's actually put nothing there. So, and also we're going to have matrixes size of matrices divided by size of matrices 0. That's what we're doing. You gotta use dollar. No, I meant the command ASCII. ASCII Sojin W, for example. And the bot is dead, by the way. You cannot even use dollar. I'm sorry. Yeah. Didn't donate, didn't work, yes. Have to donate first. Bot is dead. Alright, and we're gonna have our final matrix. So the final matrix is gonna be actually mat for IDs, not got it. Oh shit. So remote. Well, now I have to fix the bot. By the way, thank you so much for 500 bitcoins. Thank you. Now I'm actually have to fix the bot because somebody used the dollar to you know, to do this thing. Just a second, I'm gonna try to fix it real quick. Yeah, 500 bitcoins. 500 bitcoins. Where is my bot located? I don't remember where is the bot located, to be fair. Can somebody ping the bot? Can somebody ping the bot, please? Bing. It worked. What about the old bot? Both of them worked. So now you can do ASCII Zozin W, and it works. So you see, you just have to use dollar. Thank you so much, Simon, for 5 bitcoins. Really appreciate the help. Really appreciate the support. Yeah, you see, now it works. Now it works. Oh shit, you need to update the BTTV modes, and I'm still using old BTTV API. I'm so bad at bot development, holy shit. To be fair, the problem with the bots is that they require too much maintenance. Because the code in the bot deteriorates really quickly, it just rots very quickly, in a sense that you write a glue for APIs, right? You write a glue for APIs, and those APIs are constantly changing, right? So your code gets really quickly outdated unless you're constantly maintaining it. You cannot just write bot once and use it for the rest of your life. Like, it's just not a thing you can do. So that's probably why I'm so bad at you know, bot development, because it requires like constant maintenance, like fucking every day. I'm pretty sure Supinik would agree with me, or Pylada, like people who actually have to maintain their bots like 24/7. Like, if you don't maintain your bot, it's just like it becomes trash very, very quickly because it gets outdated. So yeah, that's probably why I'm so bad at it, because I don't know how to do that. The cool thing about command line utilities or self-contained utilities is that you can just write them once, right, and they will just work. They will work in 10 years, they will work in 20 years, as long as the API they depend on is stable. Like, POSIX is actually pretty stable, right? So, and the stability of POSIX is guaranteed by big corporation businesses and military entities, because they all depend on POSIX API. So yeah, the stability of these APIs are guaranteed by very powerful entities. So anyways, let's actually do the following thing. POSIX, yes. We're gonna iterate through all of the matrices. And what we're gonna do is gonna be mat4 mult mat4, and we take the matrix and we take the matrices and we multiply them together and we assign them back. In here. Write anywhere, run once. Nice one. It's like a, I guess it's a graffiti. You write it anywhere and you just run once after that. Run away once. All right. So basically, this enables us with defining like a sequence of matrices that will be applied sequentially. Right? You know what I mean. So yeah, let's actually put that matrix into the shader. Let's put it into the shader. By the way, you shouldn't actually set uniform if the compilation of the program failed. This is actually not a thing you can do. So yeah. Where is my location? So I want to introduce something like GL int matrix location. I'm pretty sure I already have the matrix uniform in here, so I just need to basically set it. So when we're reloading the shaders, after reloading them, I get the location of different uniforms, and I think I'm gonna do the same thing with the matrix location in here. There we go. So now what we're gonna do here is just set the matrix. But let me try to get the Chromium. Docs.jl. GL get, I think it's something like uniform. Yeah, we're gonna go into the uniform. GL get uniform matrix It's actually not get, it's a GL uniform matrix. For the, yeah, we need this one. We actually need this one. Godbolt! Godbolt is my favorite game engine. I love Godbolt. Okay, so we're gonna put something like this, matrix location. I want to actually tweet that. I just realized that it's actually tweet worthy. Let me just quickly feed that. Godbolt is my favorite game engine. Godbolt, yes. Alright. So, yeah. Because I need some shitpost content on Twitter, okay? So I'm supposed to be a content creator. So, anyways. So yeah, by the way, follow me on Twitter. Do I have Twitter in here? Yeah, I do have a Twitter. I don't know why. I think it's absolutely fucking horrible social network, and I absolutely hate it. But apparently, since you're a content creator, you're supposed to have a Twitter, and you're supposed to grow it. I guess that's what I'm doing. Yeah, I absolutely. It's such a fucking trash. So yeah, holy shit. Anyways, so here's the matrix location. So count. What is a count? Specifies the number of elements that are to be modified. This should be 1 if the target uniform variable is not an array. Ah, sure. We do remember from the previous stream that we do have to transpose it. And then we have to provide the matrix, right? Nah, that bot is down, Columbetka, I'm sorry. And the code, by the way, that I used to generate that is already gone because it was filled with buffer overflows and shit like that. Imagine actually exposing to the internet like buffer overflows and shit. So yeah, it was offline. You missed it because it was offline. So yeah. But we're gonna re-implement it one more time when the next bot development stream is gonna be about. To be fair, like, I'm so actually goddamn scared to write a code, a bot in C, right? So, like, I need to like put it behind several like containers and virtual machines in case somebody will try to, you know, fucking pawn it. Because I'm not really sure if I'll be able to catch all of the like buffer overflows and shit like that. Maybe I should just use Rust. How about that? What do you guys think? Should I just switch to Rust instead? Maybe I could try to program in Rust like in C. Yeah. So that would be kind of cool. I didn't want to say it, but yes. Sure. I'm sorry. Okay, so this shit didn't compile, by the way. Mat4. We don't have a Mat4 ID? What the fuck? Why don't we have a Mat4 ID? Mat4 ID. This is gonna be this. Rust makes me .wet. Yes. Rust turned me into a .wet developer. So where am I gonna put all this shit? I think I'm gonna put it somewhere here. Let's return mat4. C++ like JS like C, now Rust like C. Yeah, I can program in C in any language. Seriously. Alright, so how do you define an identity matrix? I don't know. I don't have a formal education in math, so I'm really sorry. I don't know how to do that. Can anyone tell me how to define the identity matrix? I literally don't know. It's kind of like beyond my knowledge. Okay. So what was that? Okay, seems good. So void star. And yeah. So we're successfully passing a matrix into the shader. Now, what we can try to do, we can try to multiply that matrix Actually not here, but rather here. So there we go. So that should apply the transformations. But as you may notice, it doesn't apply any transformations because we don't have the like any transformations at all. We don't have any transformations at all. Let's actually put some transformations there. Matrices. So the first transformation, as already said, right? So the cube is generated in 0, 1, 0, 1, 0, 1. 0, 1, 0, 1, 0, 1. So we need to shift it, right, at minus 0, 5, minus 0, 5, minus 0, 5, yo. Right. So let's quickly try to do that. So it's going to be mat for translate minus 0, 5, 0, 5, minus 0, 5. It's actually not minus 0, 5, minus 0, 5. And I guess that's enough, so that will automatically translate it, hopefully. And it did. Would you look at that? So we just use the matrix to translate this shit. Isn't that cool? I think it's goddamn fucking cool. So maybe we can also try to scale this entire shit afterwards. Right, so for example, since it's only like half of its size, it doesn't fill the whole cube. Right, the whole minus 1, 1, minus 1, 1, minus 1, 1 cube. Minus 1, 1, minus 1, 1, minus 1, 1 cube. So we can try to multiply that by 2. So let's see. Will that work? Will that work? We'll see. We'll see. Something worked, but not really. Maybe it has something to do with the order of the matrices. Yeah, I forgot to put it like this. Yeah, it was. So now it's correct. So essentially, even though we multiply matrices for like from top to bottom, the operations are applied in a reversed order. Who knows why? Who knows why? Matrix order of precedence. It doesn't really explain that well why. So it's just like a random word which doesn't mean anything. Bed max. That explains everything. Alright. Because it's C. I don't think it's because it's C. I think it's specifics of how matrices work. I think it's more of a specific of this shit. So, imagine that you have a vector and a matrix, right? So here is the vector, right? And you have a matrix 1, and you multiply it. So, and this is how you apply this operation, all right? So, to apply another operation, right? You multiply that by another matrix. You see, you apply this operation, and then you apply this operation. So to apply another operation on the vector, you multiply it by another matrix. So what's interesting is that matrices have the law of associativity. I forgot the name. So associativity law. Is it associativity or something? Yeah, it is. So basically they are associative, which means that this shit is equal to M3, M2, M1 multiplied by V. That's why. Right. So essentially they're going to be applied from the closest matrix to the vector. So they're going to be applied in this particular order, and it doesn't matter in which order you multiply them. Like, it literally doesn't matter in which order you multiply them. They're still going to be applied in that order from the closest to the vector to the farthest from the vector. As far as I can understand what the fuck is going on with matrices, I think this is how it works. So that's kind of the property of the matrices. That's why everyone, by the way, likes them, because they're like a really great way to encode operations. You can just have several operations and you can essentially just collapse all these operations into one without losing much information. And somebody at the beginning of the stream, somebody asked about matrices being monoids. Yes, as far as I know, matrix with multiplication define a monoid. I think it does. Along with the identity matrix, because for the monoid you need not only a set of elements and binary operation, you also need a neutral element. Without the neutral element, it's going to be semi-group, right? So without the identity matrix, it's going to be semi-group. But who fucking cares? All that shit is for nerds. So Haskell and OpenGL, it has nothing to do with OpenGL. This is a linear algebra. It's more of a... And furthermore, semi-groups and monoids have nothing to do with Haskell either. Linear algebra has nothing to do with OpenGL. It's its own thing, and monoids are also not part of Haskell. It's from abstract algebra. Right. Debated into linear algebra yet again. Matrices form a ring, lol. Does it contradict to what I said? I don't think it contradicts to what I said. I think I said that matrices, multiplication, and identity matrices form a monoid. The fact that you can, with matrices, build even bigger abstraction like a ring doesn't contradict what I said at all. So, oh, I see. Okay. So we can actually build more sophisticated algebras with matrices. Okay, sure. I know nothing about linear algebra, so... Oh, specifically square matrices. Yeah, this is actually quite important. Square matrices, because matrices are like more general things. Let's make a cup of tea, chat. Let's make a cup of tea. I still don't understand perspective matrices, so it's gonna be fun. Well, I do kind of like vaguely understand perspective matrices, but I'm not sure if it's gonna help me too much. So it's gonna be yet another fun stream, just like you like it. By the way, chat, look at the amount of views. Look at the amount of views. It's actually lower than it was yesterday and the day before yesterday. Guess why? Guess why? Because I put boring nerdy shit into the title. You wanna see what's gonna happen if I change back to the original title? What's interesting is that I'm doing the same shit, by the way, that I did yesterday. I'm doing the same shit. I just put something like very nerdy, very mathy into the title, and like, you know, the quarter of viewers is just like gone. So, and without changing any of my activity, I'm gonna change back to 3D graphics in OpenGL, and within like maybe 10-20 minutes it's gonna actually rise it a little bit better. We'll see. I want to just conduct an experiment. So now the title is 3D graphics in OpenGL. So let's see how many people will be able to debate into linear algebra. Debating is in progress. What if you change it to just multiplication? That's a good one. Multiplication. Alright, so we want to do a translation. Should we invest in TSO now before the rise? Not yet. Okay, so here is the thing. So we scaled everything. Now we probably need to put the square into the camera view. right? But we need to define the camera view, and camera view is going to be actually defined by the perspective, right? By the perspective. But before we're going to do that, I want to test my rotation matrix. So what kind of rotation matrix do we have here? What kind of rotations matrix do we have? Oh shit, it's really not gonna work. Let's actually put followers off, but I'm also gonna zoom in the chat just in case. So we're gonna zoom in the chat, so in case there's some sort of like a very gotcha-gasm art, nobody's gonna see that. So I'm gonna do bra sodium W. Let's see how it's gonna. Yeah, it's gonna be look all scuffed, so we'll have an opportunity to actually ban the person before we show the art on the stream. Yes, yes, yes. Or maybe it's still gonna be visible. I don't know. Okay, go. We'll see. What I was doing? Oh yeah, I wanted to see a rotation. So let's actually rotate around the y-axis. Rotate y, and the angle is gonna be. Let's actually use like 3, right? Ideally, it would be nice to use the time as an angle, I think. What the fuck is this shit? Is that because the scale is too big? Let's actually not scale this entire thing. Alright, so we're applying translate, then the scale, and yeah, that should be right. Yeah, it feels like it clipped a little bit. Oh yeah, it's actually clipped the corner. Yeah. So the corner got slightly clipped, I think, but not really. Oh yeah, okay, bye-bye, useless spawning, bye-bye. Alright, so let me see. So what I want to do here is probably move this entire stuff into the title, right? I want to move this entire stuff into the title, and yeah, let's put it here. So we're generating it here, and we're going to be using time as the rotation angle. I'm going to be using time as a rotation angle. And there we go. So, but we're doing all of the transformations on CPU as an opposite of GPU. So, which is okay, I suppose. We can also do the Z thing, right? So as you can see, all the matrix mathematics works out. All of the matrix math works out. Okay, I'm gonna go to the kitchen and turn on the kettle. Please don't post any dicks in the chat while I'm in the kitchen, because I want to see all of them. Okay, so I want to see all of the dicks. All right. Cool. That's pretty cool. So what else can we do here? We can probably speed it up, I think. I think you should be able to just multiply time by 2, and that will make it a little bit faster. That will make it a little bit faster. All right. Look at them go. Look at them go. I think it's actually pretty cool. Oh shit, I didn't want to do that. Alrighty, so what do we got? Now we need to do the perspective translation. So essentially, we're gonna assume that Z is forward, right? Z is forward. I mean, minus Z is forward. That's what I wanted to say. So that means we need to probably blow out the entire cube into, let's say, maybe 25 but by 25. Yeah, 25 by 25. So it's gonna be like this sort of cube, right? So we're moving it to the center. It's 1 by 1 by 1, and we'll multiply it by 25. So it becomes 25 by 25 by 25. All right, so this is the cube. I don't really plan to rotate anything here. So after that, I want to move this thing away from me. Right, I'm gonna try to move it away from me. So it's gonna be, we're not gonna modify the X and Y, but we do want to modify the Z. So if it's 25 by 25, but by moving it 25, we actually move it slightly. Yeah, I think we can move it like minus 25. All right. Does all of that make sense? So we have a mesh 0, 1, 0, 1, 0, 1. We shift it by minus 0.5 so it stays at the center. Then we blow it up to the size of 25 by 25 by 25 with the center at the origin of the coordinates. And then we're moving it away along the z-axis, along the -1 by 25. You see what we're doing here? Does all of that make sense? I think it does make sense, right? So everything so far makes sense. So the next thing we need to do after that, after we actually established like the cube somewhere here, we need to do a projection, a perspective projection, perspective. But the question is, this is where it doesn't fucking work. So I tried a lot of different perspective matrices, and I think there's only one thing left. We need to steal it. We need to steal the projection matrix. That's what we need to do. And that's what we're about to do. We're about to commit a crime of stealing the... But we're not going to commit a crime. It's a joke, by the way. Twitch, don't ban me. Don't ban me, please. It's just a joke. Alright, so let's continue. I'm going to just pour a cup of tea. And I'm going to be back. Don't post any cocks without me. I want to see all of the cocks. Cool. Nice. GLM. Generalized linear model. Thank you very much. GLM C++. OpenGL mathematics. Cyber forum time. What the fuck is cyber forum? I cannot stop, I'm sorry. Let's just do committee. Not committee, but clone. DMC incoming. Don't stop. So let's see if we can steal the code. So GLM, we have mat 4x4. So there's this kind of shit. I want to try to do. I want to try to find perspective. Perspective. Can we find anything perspective here? So there's a perspective matrix. All right. So here's that. Something called perspective. It's inl. I don't know what the fuck is inl. So probably some sort of like a for generating code and whatnot. I remember that the function had like it was just literally called perspective, as far as I know. I think it's literally called perspective, and I think I found it. So if glm config clip control equal to lhzo, oh, let me switch to simc mode. So there are several perspective matrices apparently. Oh, it's a left hand. Okay. ZO. What is left hand ZO supposed to mean? Okay, left hand, but ZO, I don't understand what ZO. So which one do we have? We have, I guess, I think it's a right hand. Oh, let me actually Google up. GLM clip control LHZO, because it's quite important, I think. Excuse me? And Google, you're so useless, holy shit. Zone out. Okay. Well, I mean, I literally found it. In Russian, by the way. Why is it in Russian, exactly? That's really strange. I just don't understand what ZO stands for. Like, I do understand left hand, but what is ZO? Nobody knows either, apparently. Because left hand and right hand is easy to guess, but what is ZO? I don't know. Maybe... yeah. Well, the Russians are curious enough. Yeah, I can see that. Left hand coordinate systems. So how do you distinguish them? Okay. Let me see. Finding cross product by right hand. No. Left, right. I forgot how to do that. Oh, 0, 1. Ah. Okay. And what is NO then? 0, 1, and what is that one? Negative. Maybe we can actually search for where those things are defined in the code itself. Let's actually look for them, and where are they defined? Okay, 0 to 1, negative 1 to 1. Okay, so here they are. I should have actually like grabbed for them like in the first place. Alright. So, and let me double check if I understand like left and right-handed coordinate system correctly. Left-handed coordinate system, okay, so... Alright, so that makes sense. A right-handed system is... Alright. Code equals documentation, yes. The default coordinate system in the RenderMan. Any RenderMan in the chat? Interface is left-handed, the positive X and Y. Z-axis pointing right up and forward respectively. Okay. So right-handed is when Z is outwards, like with negative. Positive rotation. I think we have a right-handed one then. If the negative is gonna point there, I think it's gonna be right-handed in our particular case. So it is right-handed, and it's negative 1, negative 1. Negative 1 to 1, yes. So in our case we have right-handed NO. That's what we have. Right-handed NO. Wait, left-handed. Right-handed. Okay. All right. So what was the other thing? Perspective. Yeah, I have to go to the SRC, or maybe somewhere here. Alright, so this is gonna be that. Right-handed NO. Let's try to find right-handed NO. I'm pretty sure it's in the same place, but I don't know why I decided to Google it one more time. Alright, so okay. So what this thing accepts, it accepts FOVI, aspect, Z near, and Z far. So we just need to copy this code. We just need to copy this code. And I think this is precisely the code I've seen in all of the goddamn tutorials, including like, including the signs. Like the signs are fucking the same. Yeah. Sergeant TOS and TOSC. I'm not really stealing the code right here. By the way, chat, I found this matrix in a library without architecture MD. Holy shit, almost broke my second plate. Yes. Yes. You don't need architecture MD. You just need to learn how to navigate in someone else's code. You just need to learn how to navigate in someone else's code. Yes, you need to spend time practicing a skill. I'm sorry to tell you that. No architecture MD. By the way, Foxy, I think the time has come to trust you. To see food. Yeah, let's actually trust you. There we go. Because I've seen you around for quite some time already, so I think the time has come to trust you. Okay. Pogi Wogi. Are you 15? Okay. With the great power comes the great electricity bill. Ah, funny joke. Cheers, by the way. I'm about to steal that code. All right. Go.c. No, go.h. So we're gonna have something like mat4 perspective, right? This is perspective, and what we're gonna accept in the is gonna be FOVI, Pogi, Wogi. I feel more proud of being trusted in this channel than being promoted at work. Why? Am I trusted, by the way? Am I trusted? Oh yeah, I'm trusted. What is the Y in FOVI? It basically means it's vertical. It's a field of view vertical. That's what it stands for. Vertical field of view. All right. So then we're gonna have aspect, and then we're gonna have Z near. I'm gonna call it just near, and then I'm gonna just call it far. Yeah, that's basically what we're gonna have here. Let me copy paste this entire code. Go-C, there we go. I really like this idea of just having a result which is 0 initialized and just set specific like coordinates in here. It just makes it a little bit easier to read in general, right? And then just return the result. I think I'm gonna use the same technique in here as well. I suppose the first one is a row based, right? So this is a row based. Oh my god, I need to double check if it's a row column and not column row. Fuck. Okay, this is already painful. Alright, but one thing I can do probably is just bookmark this entire thing, right? So then later I can go to bookmark menu, I think, and just I forgot how to use that, bookmark list. Yeah, I can then just go here and just jump back. So you can bookmark places in Emacs. Can you, Vim, do that? Can you? I don't think so. I don't fucking think so. All right. So what do we return here? We also have mat, which I presume a class, right? Which I presume a class. Let's try to search for that class in here. So it's gonna be class mat. Let's see. Do you find it? I think I found it without any architecture MD. How about that? Well, almost. Well, I tried. So, okay. Can you have it like? Oh my god! It's probably have like, yeah. There is no such class. Maybe it is like a using. No, it is not either. So I have an idea. What if we're gonna try to find all of the files that start like this. So here are the files that we're trying to find, and first of all, type file, and name is like that. So here are all of the like CPP and HPP files, and we're gonna pipe all of these motherflippers into the e tags, right? And now we have a huge e tags file which will help us to navigate quite easily. Right, so here are all of these things. So I'm gonna go to bookmarks B menu list. I'm gonna go here, and then I'm gonna say, can I jump to the definition of this thing? And I can provide the tags file. So there's a lot of places where this thing is sort of like defined, but it's not really a definition per se. I don't really see a definition per se, so it's not helping. So these are just usages, but they are not definitions. It just found all of the usages. Okay. Emacs is life. I hate my life. Well, don't hate your life. Come on. Valentin, thank you so much for 19 months of tier 1 subscription. Dab. Thank you. Holy shit, that's a lot of months. Thank you so much and welcome to our epic IDE. Oh shit, I actually spilled some water on my pants. Now I look like I peed myself, which is okay. I do that every time anyway. Okay, so... Oh, it's a struct! Okay, it's a goddamn fucking struct meat. Alright. That's kind of interesting, so the... Okay. Operator. Yeah. So what kind of operators did they overload? It's probably operator. Yeah, the thing about C++ is sometimes it's just really difficult to find all of these definitions. Yeah. I really want to pee, by the way. So let's make a small break, chat. So it's gonna be like 2 minutes, I think. Template circus, exactly. It's that what we have here. In C, it would be super easy to find everything, but in C++, yeah, you just have to. Well, to be fair, GLM is actually okay for a C++ library. I've actually seen worse template circus, so it's fine. It's actually pretty easy to navigate in it. It's not that complex. Didn't you pee your pants just... Well, it was a fake pee, so now I need to pee for real. So yeah. All right. Let me see. Yeah. Okay. No, this is not what I want. Let's make a small break, and you guys have fun. Don't post any cogs without me, please, because I want to see all of the cogs. Thank you so much. Yo, did we have any cocks? We didn't even have any cocks. Okay, that's sad. But hello everyone, welcome back. So what is that? Cocking? Oh yeah, I know this emote. It's actually pretty cool. Thank you. You probably saw that emote in Pilata's chat. Yeah, I know that for a fact. Added it to the channel. Thank you so much. Lots of cocks. Yeah. Oh, I need to reload my emotes. Stephen Hawking, the famous physicist. Rest in peace, by the way. Stephen Hawking. Yeah, I think it's working. So we also have a role type. Yep, Stephen Cook. Alright, so there's the operator. I just don't really know. Okay, so by accessing this thing, we get a column type. Which means that this thing accepts a row. And within a column type, this is a vector, right? Okay, so that makes sense. That makes sense. All right, so let's go back in here. So that means this is a row and this is a column. I know that for a fact. I checked the types. Imagine being a doll in 2021. Oh my god. Chat, never grow up. Growing up is a trap. Never grow up. I'm 30 years old and I still didn't grow up, so look at me. Look where I ended up. Anyways, so result. Peter's. Holy shit, like, yes, I do feel like I'm a Peter Pan, seriously. Anyways, so what do we have? So this is a 0, 0, and this is the 0, and essentially here we just take this and we multiply the aspect by 10 half 4v. It's like Poggy but 4v. And in 10, 4v essentially is 10 half 4v. It's gonna be equal to 10th 4v static cast. Well, I mean, why am I copying it like that? I don't have to statically cast anything, so this is gonna be just a 4v2. And you know, you don't have to divide it by 2, you can just multiply it by half and it's the same shit. Is it not? I think it's pretty much the same shit. Remember Peter Pan growing up with Robin Williams is pretty blessed. Oh yeah, I want to rewatch it actually. Holy fuck. Yeah. I remember watching that movie when I was a kid, it was so good. Well, Robin Williams generally is actually a pretty good actor. For kids movies and stuff like that. Viewers count increased by 20, by the way. Yeah, so it's kind of like it has like, if you didn't put a clickbaity title at the beginning of the stream, it has less impact, right? So because people didn't get those titles in the notifications and so on and so forth, so it does increase the viewership, but it's just like has less impact if you started with that title. So yeah. Let me see. So this is gonna be a result vs. So this is the aspect, and then we take this and we divide 10 half 4v. This one is 2, 2. So this is the far divided by near minus far, right? Near minus far. Result vs 2, 3 minus this. And I suppose this is a very interesting assert. So you take an aspect and you take an epsilon. Oh, that's interesting. So epsilon is for the floats, I suppose, like the possible, like, wait a goddamn fucking second. Numeric limits, I want to check it out. CPP reference. 3. Alright, so I didn't want to click on that, right, bruh? Numeric limits. There we go. Okay, I'm not gonna comment on that. Sure. Epsilon, there we go. Difference between just the machine epsilon, that is the difference between 1 and the next value represented by the floating point t. It is only meaningful if... okay. Oh shit, that's actually a pretty useful constant. So you can use that for like rounding things and whatnot, and that's pretty cool. So it's like smallest possible thing. So aspect you... I see what they're trying to do here. That's actually... Huh. That's a very specific check. So something may break if it's not working. Huh. This is the reason why I like to read someone else's code, because you're like discovering these little interesting things. Division by 0. I guess, but where is the division by 0 here? Ooh. Okay, sure. Yeah, I see what's going on here. So result vs 3 2 minus far multiplied by near divided by far minus near. All right, so I think that's it, pretty much. That's it, pretty much. Perspective. So maybe we're gonna put a note. Note stolen from GLM. We can even put the specific function. Something like this. Stolen from here. Geo.h. So now we just need to craft a specific call, right? We need to craft a specific call. So here's what we're doing here. We, as already said, we have a mesh 010101. We translated it by -0.5, making it centered at the origin of the coordinates. Then we blow it up to 25 by 25 by 25, centered at the origin. So we have that. After that, we translate it along the z-axis away from us, because the z goes forward, so it's going to be -25. So this is going to be the cube somewhere there. And after we put the cube of appropriate size in front of the camera, so this is basically our camera matrix. If you, yeah, so you can treat it as a camera matrix essentially. After that, we have to do the perspective thing. Field of view. What kind of field of view we're gonna have? So aspect. The aspects can be just screen width divided by screen height. I might as well actually put that aspect in here. So it's gonna be float aspect equal to that. But both of them could be potentially integers. So I want to make sure that they're floats, so we don't lose any of that juicy precision. So near, right, so we have a cube 25 by 25 by 25, somewhere between, like, let's say maybe 1 and 100. I think that kind of makes sense. So let's put it between 1 and 100. So maybe I want to even translate it slightly further just in case. And I think this cube fits perfectly between like 1 and 100. It should be visible there, right? So, well, I mean, if it's negative, we have to use the negative, right? So this is like negative negative z, right? So the last thing we need to have the field of view. Field of view is very interesting. Vertical field of view. What's going to be the best field of view? Is 90 degrees okay field of view for this kind of shit? What do you guys think? What field of view is the best one for this kind of stuff? And also we probably need the pi constant. Pi. So we're gonna put it somewhere in a GL. So because it's related to geometry, and this is gonna be pi. It's gonna be float. I guess maybe it's gonna be a good one. I don't know. I don't know how good of a pi this is, but it's kind of it's pi. So let's try 90 degrees. Let's try 90 degrees, and to convert 90 degrees to the radians, we need to multiply them by pi, if I remember correctly, and divide it by 180, right? So something like that. Is that how you convert them to radians? I think this is how we do that. Screen width by screen width. Yeah, we need screen height. Thank you so much. Yeah, so I might as well actually put how can you code so many things? I'm coding only one thing right now. Well, I'm coding one thing at a time. At a time. So this is going to be 4v. So yeah, so the secret is actually, it's kind of sad. I'm constantly depressed all the time, and coding is basically my way of coping with depression. So yeah, it just works for my brain. So basically it allows my brain to forget about everything and just focus on that specific thing. So yeah, I'm not even joking, seriously. That's why I code so much, because I'm hella fucking depressed, and that helps me to cope with depression. And I'm not saying that it's a great way to cope with depression, because it may not work for everyone, but it works for me. So yeah, it just like distracts me from everything. So yeah, that's the secret. That's my dirty secret. Anyways, so what do we have? And I've been using this as a means of coping with depression, like since I actually started coding, actually, believe it or not. That's why I became such a passionate programmer, because holy shit, I discovered a way to forget about my depression. So, and I kept using it, and yeah, it was actually great. Since I was 16, I think, yeah. So I started to code when I was 16, and yeah, I guess. Just don't be sad. Yes, just don't be. Oh my god, what the fuck is this Emacs? All right. Anyways, I'm not sure if it will work. I'm pretty sure it's not gonna work, because I tried different kind of like ways of defining this perspective and whatnot so many times, and none of them worked. I'm pretty sure this one is not gonna work as well. Okay, let's actually go through all of that one more time. So I'm not gonna apply any transformations, and let's see if it's gonna do anything. This is not what I wanted to do. I really like this emote. It's like, this is the hand, and this is the eyes and the mouth, and there's a PP in here. Anyways, so let's recompile that. Let's recompile that and see if it's gonna work. So we have a bunch of unused variables. Okay, so that makes sense so far. So I just want to go step by step and make sure that we understand everything. We're moving everything to the center. Oh, well, I forgot to recompile. Don't forget to recompile your program. Otherwise, you're not going to succeed on the John Blow stream. All right, there we go. So then we scale it to 25 by 25 by 25, right? That's literally what we do. And oh shit! Oh fuck! I'm running it one more time, and we should be able to see anything. Okay, so essentially, it's 25 by 25 by 25. And it's so huge, it's around us and it's outside of the clipping planes, because as far as I know, OpenGL clips around like -1 and 1. right, oh, like in Z, right? If your Z is outside of 1 and -1, it's actually gonna clip away. That's why you need to sort of map everything within that cube of -1 from 2 to 1, right? So that's why we don't see anything. So not seeing anything actually makes sense in this particular case. So how can we make, how can we able to see something? Well, we can try to move the cube so we see it's a front face, right? So since it's 25 by 25 at the center, we need to move it -25 divided by 2, right? -25 divided by 2, so the cube's face is going to be in front of us, so the cube's face is going to be like literally 0. And if we will be able to see that, that means we do everything correctly and I do understand what's going on. Otherwise, I don't understand what's going on at this point anymore. And yes, we do see something. So it's a color of the skin of the emote, right? Since the cube is so goddamn huge, right, and we don't project it, we don't do anything with it, we just see whatever we see, essentially, right? Yeah. So everything makes sense so far. Everything makes sense so far, but we were moving it like to -30. We were moving it to -30. Okay, so now we don't see anything because it's clipping away and we're not supposed to see anything. Now the time has come to project that shit. So it's somewhere from 0 to -30, 25 by 25. We're gonna put the plane -1 to -100. I'm pretty sure such thing will fit there. Okay, well, we can probably put something like 500 just in case, right? So aspect ratio is the aspect ratio of the screen, so screen width by screen height, and the 4V is 90 degrees, like a vertical field of view. Is 90 degrees good enough? So what is usually field of view in games in Minecraft? I think it's like around 90 degrees. Does anyone know? Do we have any professional gamers in the chat who knows this kind of shit? Because I don't play video games, like I know nothing about video games. It's not like I was almost expelled in my from my like middle school because I played too many games. No, I don't fucking play video games anymore. Precisely because of that. So 80-90 is quite standard. 75 consoles, 90 is usual, and I set it for 110. Okay, that makes sense. Thank you. So we're gonna keep it like that then. All right. The only thing that is left is probably to double check that we copy pasted the matrix correctly. But okay, we're ready to see something at least, and it doesn't work. So yeah. Doesn't work. This doesn't work. Classic. We can take a look through through the vertex shaders and stuff like that. So here's the my vertex shader. We put the matrix in there. So we multiply by vertex position and everything looks okay. So here's an interesting thing. After we applied, we can actually move that thing away from the loop because we keep reapplying it every iteration of the loop because I wanted to animate it. We don't really have to animate it. We can put it here. So now let's actually apply this matrix manually. Try positive far, but negative near. What about negative near? But I mean, I placed square at the negative axis. How using positive far makes sense? Okay, we can try to put positives here. Okay, so I'm pretty sure it's not gonna work. Oh. All right. Okay. But it's supposed... Okay, so near is sort of... Okay. Homogeneous matrices, I suppose. By the way, fellow Fort, welcome to the stream. Okay, so let me now try to do the epic animation. And the epic animation is gonna reveal if we succeeded in the game industry. I'm about to start rotating that shit around Z-axis. Okay, so we're moving it to the center, and I think this is a good place where we can rotate it, right? So it's gonna be rotate around Y, right? We wanna rotate it around Y, and we're gonna use the time as the angle of rotation. After we rotated it, we're gonna blow it up to 25 by 25, then translate it to -30, and then project it. You see what I mean? So because of that, it will rotate around its own axis and not around origin, right? So that's why we're rotating before translating. So we can actually swap around scale and rotation. It just doesn't matter in which order you do them, but it does matter in case of a translation. So let's see if it's gonna work now. Yeah, I wrote metric separations myself. So yeah, so it's actually quite convenient that I can put matrices into array and just collapse them all into like with this separation. Let's see. So here are perspective metrics. We actually stole it from JLM. Rotation metrics were stolen from Wikipedia. Translation and scale matrices I code myself because they're very, very simple. And multiplication I just coded myself as well because they're very simple. It's a 4x4 matrix. It's not that hard to code them. So majority of the math is actually done manually. We don't have any third-party dependencies except of GLFW, right? We don't use any math libraries or anything like that. But it looks like a triangle instead of a cube, but maybe it was supposed to do that. Yeah, I think it has something to do with the perspective. I think it has something to do with perspective. Maybe we can... Oh yeah, holy shit, I managed to do that. Alright, so what if we try to rotate it by several axes? Let's try to rotate it by several axes. So another one that we have is Z. Right, so we're rotating by Y and then we're rotating by Z. And let's see what we have. Now it looks like a cube. That's pretty cool. So this is a sodium flushed. Oh shit, cheater. Oh, cheater reconnected. So that is goddamn fucking satisfying. And I don't understand why the fuck, if I try to do that in a shader, it doesn't really work. But now it goddamn works. Okay, so here's the thing that we can try to do now. Now we can try to do something else. So I'm gonna go to the fragment shader and we can try to apply different things. We can try to apply the fog to make it a little bit more scary. Well, yeah. It looks kind of strange, but it looks okay, I suppose. So the fog... Oh yeah, Z-axis... Yeah, it's probably too far away. Fog shader incoming. We already have a little bit of fog, but it's just like makes it darker because Z is not big enough or something. But yeah, so let's do something else. Oh shit, it actually didn't compile. I'm sorry. Oh shit, I'm sorry. There we go. But it looks so cool. How can you visualize this? What do you mean? How can you code something like this? You spent 3 days banging your head against the wall without understanding anything. That's how we do that. That's how I did that though. Was it worth it? Maybe. I don't know. That was interesting at least. Oh, by the way, I can stop the time and I can move backwards and forward in time. So that's the thing you can do. I think it's pretty cool. Did it show? Yes, it reloads shaders live. So I'm using my own template that I wrote for OpenGL. You can find it here. So this is a pretty useful template which automatically reloads the shaders for you, so you can pause and unpause the time and how to reload the shaders. And this entire code is almost 300 lines of code, so it doesn't have that many abstractions. It's actually pretty straightforward. It doesn't look like a cube to me, but it's very cool. I think it's because like it's too close, I think. Is this the making of a sodding spin gif? Maybe. I don't know. Unfortunately, we cannot hot reload the texture. It will be kind of cool to hot reload the texture. So I'm gonna put the pog in here. I mean, we already had a pog. Yes. It's because the field of view too big. We can try to change the field of view. Yeah. So now this is a pretty epic pog. They look at each other. Look. They look at each other. This looks cursed. Holy shit. What the fuck? Okay, so I'm gonna tweet that. No kiss. Yes, exactly. Easy. Go away this. Okay, that's pretty cool. I'm sorry, I was just, surfing Twitter. I'm sorry. So I forgot that I'm streaming, and I was just scrolling through Twitter and just checking some tweets and stuff like that. Yeah. I mean, if you're allowed to scroll Twitter at your workplace, I'm allowed to scroll through Twitter at my workplace, okay? So... I kind of want to be able to modify the parameters of the projection and rotation inside of the shader and hot reload them. I don't really want to do that in the on the CPU. So I wonder if I can move all of that logic inside of the vertex shader. You know what I mean? That would be kind of cool. Like move like everything inside of the vertex shader, so I can modify it and see how it goes. But people tell me that you're not supposed to do this kind of shit in the shader, but it looks kind of convenient, I think. Anyways, I think what we need to do now, we need to do a committee, and then I'm gonna try to attempt to move all of that logic inside of the shader. Since we have working everything on CPU, we can try to make it work on GPU as well. Alright, so I'm gonna remove all of that shit. That shit is not needed anymore. And what do we have? Okay, make the rotating cube actually work. Now let's push that right into the repo. So what do we have here? So we have a texture the cube. We managed to texture the cube. Simple shading. It was made with the fog, but I want to try to make it like with normals and stuff like that. You know, people associate with each triangle a normal going out of the triangle, and then they just use it to calculate the brightness of each individual fragment based on all of that. So we can try to do that as well. I think it would be interesting. So I'm gonna actually antique this and that stuff and see how it goes. Simple lighting, the classical one with normals and stuff. Also, let's try to recover fog, right? Let's try to recover fog, because before projection, fog was super easy to implement. So now, I guess the reason why fog doesn't look as great anymore is because the Z became too big, right? Because we used to use Z as the way to interpolate, as an interpolator. So we probably need to take the Z and map it to a range from 0 to 1, and then use it as an interpolator. All right, and the way to map it is actually pretty straightforward because we know the near clipping plane and far clipping plane, so we can use them as a range for interpolation, as a range of mapping to 0 to 1, right? So that's essentially what we can try to do at least. But first, before we go into all of that, I want to move the entire transformation logic and projection logic into the GPU, so I can hot reload it quite easily. So that would be cool. All right. So update the plan. And by the way, everything I do is available on GitHub, right? So the code that I just wrote is already on the GitHub. I already pushed it there. So you can clone it on your machine and try to compile it on your side and see if it actually behaves the same way it behaves on my machine. So yeah, there we go. That's pretty cool. I think that's pretty cool. Ooh, boy, oh boy, oh boy. Where is my soy? I want to make a cup of tea. Does anyone have any questions while I'm making a cup of tea? So while I'm making a cup of tea, I'm going to actually keep this thing rotating. Feel free to ask the questions. You sometimes have to do stuff the wrong way before doing it the correct way to know why it's... Holy shit, this is so deep. Gotcha, Gazan. Thank you for such a deep thought. Thank you so much. Gotcha hyper thoughts. Does anyone have any questions while I'm making a cup of tea? Sometimes you need to do things the wrong way to do them the wrong way. How about that? I bet you your quote. My quote is even deeper than yours. What's up, Jiang? Yeah, I got it working. I still don't understand how it works. And I don't understand why it didn't work before, but yeah. How about adding this thing to Suwon like a background? Feel free to do that. Both of the things are open sourced, so you can just go ahead and just combine them and see what's gonna happen. Difference between OpenGL and OpenCL. As far as I know, OpenGL is for graphics and OpenCL for general computations for compute on GPU. Right, not usually for visualization. Whether OpenCL uses OpenGL, I don't know, probably not. Have you planned your next project? I haven't planned a single project in my life. Imagine planning projects. Cringe. Alright, so I'm gonna go to the kitchen, turn on the kettle. Don't post any cocks without me. Imagine having enough energy to plan your life. Exactly, like I don't understand those people who plan things. This matrix stuff was really satisfying, yeah. It requires a lot of like precision, right? You have to be super careful because if you screw up, there will be nothing in the program that will hint you what the fuck is going on. So you have to like really like precisely. Just not forget anything, just make sure that every step makes sense, otherwise you screwed up. Next, maybe he will animate the texture. Animated texture is not that hard, I guess. I mean, if you implement the fog, you're essentially animating texture already. Yes, you're just procedurally animating texture. Lighting and fogs is basically procedurally animating texture. That's what it is, it's just a glorified texture animation. Anyway, I'm gonna go to the kitchen. Don't post any cocks without me because I want to see all of the cocks. Oh, somebody posted a Coke. Nice. Do we have to ban anyone? Oh yeah, somebody actually did. All right, so that's a ban. Yep. Nice. Thank you so much for the Coke. Was it actually readable on the stream? Wonder if I just came in. Is this still a programming channel? Why is Sony requesting D? Well, I need some D, okay? How long are the bans here? Oh boy, oh boy. Okay, so I'm just waiting for my kettle. Monarch S. All right. So I'm gonna go to the kitchen yet again. Don't post any cooks without me. I want to see all the cooks. No cocks? I'm disappointed. All right. Just a second. I need to check something. Oh shit. I can imagine how funny it looked. All right. How's it going? How's it going, everyone? How's it going? Welcome back. The lights fucked up. Yes, I broke the lights. What I was trying to do, I was trying to do something interesting. I was trying to move everything to the GPU, POG-U. So, yeah, literally move all of these things into the vertex shader. So to move everything to the vertex shader, I think we need some sort of like a functions, right? We probably can port these functions into the vertex shader. Is creating a lot of, functions inside of the vertex shader a good idea? Does anyone know? Do we have any professionals? Okay. Professional OpenGL developers. Mat4 ID. Right. If I try to define something like this, mat4 ID. Right. Oh, I can even specify void in here. What the fuck is going on? Yep. That was weird. Wait a second. Searching mat4 is already the identity. Ah, that's pretty cool. So if I should do something like mat4, that's really strange. Tags. Oh, it's gonna keep annoying me with this kind of shit. Okay. So let's actually restart the Emacs. I'm waiting for more release to run on my free BDSM. What is that supposed to mean? Excuse me. I don't quite understand. Right, so we don't need ID, but we need a translation matrix at least. Can I have mat for translate? Right, translate is going to be float x, float. Might as well actually take the direction, right? And I want to know, how do you even define matrices? How do you even work with matrices? GLSL matrices. Matrices. I need some examples to understand how it works and stuff like that. So matrices. All right, I can. They have a lot of like overloads and stuff like that, which are pretty convenient, I think. Which are pretty convenient. So I suppose I can do the following thing. Geo.c mat for translate. Yes, user is going to be a result, which is, I guess I'm going to fill it up with 0. So this is going to be just a 0 matrix. Well, you know what? I can actually do it like that. Yes. Oh shit, this is actually super convenient. And then result, row 0, 1, 2, 3 is going to be dir x, right? This is dir x. This is dir y, and this is dir z. That's the whole translation matrix. I think that's the easiest way to define a translation matrix. So a constructor for matrix takes 4 vec4s as the column, if I recall correctly. Oh, okay. As the columns. Oh shit. Oh wait, by the way, when I'm accessing this thing, is that a column or is that a row? I don't quite remember. Matrices. Oh shit, they're transposed completely. Fuck. Oh shit, oh fuck. Why would they do that? Why would they fuck up the entire math? My learner subscribed with Twitch Prime. Thank you so much for Twitch Prime subscription, your first subscription, by the way, and welcome to our epic OpenGL club. That's right. Hello. So I'm gonna pour a cup of tea to celebrate your subscription. They single-handedly fucked up the entire math. Yes, exactly. I mean, it probably was designed by a Fortran developers. In Fortran, the arrays are stored column-wise, right? So that's probably why. And old Fortran folks cannot change their habits, unfortunately. They cannot change their habits. Hello, Monica. Welcome to the stream. So yeah. Alrighty, I want to test if this. Oh yeah, I need to actually change my columns and stuff, right? So since this is I probably just have to switch them, right? So the column is going to be the third one, and then we're accepting the rows is going to be 0, 1, 2. So let's see if that vertex compiles, vertex shader. So I'm going to rebuild everything. It's going to be main. Okay, it doesn't compile. Nice. I'm so happy. I'm really sorry for such a bright color. I'm going to actually hide it away. Let's take a look. So vec4 initializer of vec4 cannot be assigned mat4. Okay, I think I did it. Really? That is really strange. But you know what we can do? We can essentially do something like that. Vec4. Look at that. Since you're accessing columns, right? Since you're accessing columns, you can do this kind of shit. I think. I'm pretty sure you can. And does it still? It doesn't compile. Look at that. 4. Yeah. Okay. So it's something 24. Oh shit. Okay. I'm sorry. Okay. Now it works. All right. So the problem was not here. but at least I discovered a cool way of defining such matrix, so I think it's okay. I think it's okay. Alright, so we have a translate matrix now. Let's actually take a look at the scale matrix. I'm gonna keep it rotating here for a while. Maybe I have a pretty cool idea. I'm gonna actually run this thing from here. So can I can actually attach to... it's not that great of an idea. If I need to make it replace your camera. Okay, let's give it a try. Sure. Why not? So let me try to run this entire thing, and it's gonna be like that. So does it work? Does it work? Yeah, there we go. Cool. So let's actually VTuber, yes. Alright. Anyways, this is me. This is me now. It's a me, Zozin Pog. Sick move. Yes. Alrighty. So we need to do the rest of the stuff. Geo.c, and we need to do scale. Met for okay, scale is going to be interesting. Met for scale, and we're going to accept vec3 as well here. So this is a vec3, and this is going to be just s. Right, but interestingly enough, can I initialize the diagonal here easily? Can I initialize the diagonal? So met for GLSL init diagonal. Init diagonal. So that'll be kind of cool. So imagine like taking vec4 and saying initialize the matrix with that by diagonally. We can probably... Can I just take identity matrix? Can I just take an identity matrix? Like mat for 1 and actually multiply a vector like that. So vector is 3 by 1, and I think that's how we do that. Yeah. Okay. So I think that will work. This is the divine intellect. Was it really divine intellect? Probably, but I mean, I have to actually do it vec4, like this. So, and that will give me a matrix, a new matrix, which is scale matrix. Yes. Okay, that's pretty cool. Let's try to now compile this, and it doesn't compile. Look at that, it doesn't compile. So return with the wrong vec4. Ah, okay, so you cannot do it like that. Okay, so because it actually turned into a vec4. So and I probably have to return mat for it to finally compile yet again. Yeah, there we go. So it seems to be working. Apparently you cannot do it like that, unfortunately. Unfortunately, you cannot easily do it like that. Okay, so that means we're gonna do it the hard way. Gotcha, guys. So yeah, might as well do it mat for result, mat for 0, right? And result 0 0 is gonna be just sx 1y 2z and 3 1. So I want to be able to do this kind of stuff. If there's like a better way to initialize the metrics like that, please suggest, because like other ways didn't work. And it seems to be compiling. It seems to be compiling, which is nice. Successfully loaded shader, as you can see. So that's pretty pogue. We need to port another one, which is, I guess, rotate. We need to be able to rotate. Oh yeah, they don't work like math metrics. It's like, and OpenGL breaks so many conventions, it's just unbelievable actually. It's really unbelievable. Vecmath should, yeah, according to math, I do agree with you, Jiang. Like, it should, but it doesn't apparently, and it's so sad, but it is what it is. It is what it is, and it isn't what it isn't. Okay, so what's the next thing in here? So we have scale, we'll definitely need rotate. I'm just thinking, if I initialize it with 1, I can just not do that. Right, I just don't have to do that. With the rotate matrices, it's going to be pretty straightforward. So mat4 rotate y, and we're going to be just accepting the angle, nothing special. Just accepting the angle. So mat4 result mat4 1. I have a reflex to actually put f at the end of this thing, but in GLSL you don't have to do that. You just don't have to do that, unfortunately. Or maybe fortunately, who knows. It just depends. So we need to initialize only like 4 variables in here. So result is going to be, so this is a 0, 0 obviously, so it's going to be cosine of the angle. There we go, so this is a cosine of the angle. The next thing, 0, 1, 2, this is the second column, but row is the first. Row is the first, so this is a sine angle. There we go. So column 0, row 2 is minus sine angle. Cool. Column 2, row 2. Column 2, row 2 is going to be cosine angle. Yep, I guess that's it. That's the whole thing. I was kind of reading about this on Hacker News about how it is incorrect assumption to believe that computer math is the same thing as the traditional math. It depends on what you mean when you say the same thing. How do you compare things? There are different conventions, but I mean, here's what I think about it. Like, right, you can define conventions however you want. And because of how you define conventions, the way you work with mathematical objects will differ. But there is something behind those conventions, like the essence of the math, that is still the same. You know what I mean? You know what I mean? It's kind of hard to describe, right? For example, the fact that matrices encode operations, right, and they compress several operations into a single sort of operation. It works no matter what are your conventions. It works no matter whether it's a column-wise or row-wise. It works no matter what. Like, there are conventions that make you work with that thing differently, but there is like this essence that doesn't change. It's like different ways of, different angles of looking at the same thing. You see what I mean? You see what I mean? So whether it's different or the same, it depends on what you mean. Do you mean the conventions? Conventions are different, but conventions describe the same thing. The essence is still there. So yeah. So it's like, yeah, conventions are different, but the essence is the same, right? And for me, essence is more important than some stupid conventions people came up with. All right. So I revealed my face for a better impact, you know, of what I'm saying. And some of those things are limited by representations, but again, the underlying mathematical principles aren't changed. Exactly. And here's the thing. People are quite, well, yeah. People quite often say that if you're like learning a lot of technologies or learning a lot of languages, you're basically being a jack of all trades, not specializing in a very specific technology. But this is not true, because that applies even in programming. So yes, you do have different conventions, you do have different programming languages, you do have different frameworks, you do have different engines, but there are underlying principles, the essence behind them, that are the same everywhere. And to be fair, people say I program in a lot of languages and I know a lot of libraries and technologies, but I do not consider myself a jack of all trades. I'm a master of one, which I called programming. I'm trying to become a master at programming. I'm trying to become a master at that essence behind all of those conventions, behind all of these languages, because the essence between them doesn't change. I'm not a jack of all trades. I'm trying to become the master of programming, whatever the fuck that word means, right? The essence behind of all of those conventions, the essence behind all of that bullshit that people put around the essence of it. You know what I mean? So it's kind of similar thing. I don't know. Whatever. Let's go back to programming. I don't know why, but this reminds me of watching the CGP Grey video because he also wears glasses. I don't know. Oh yeah, sure. It's kind of, yeah, probably. Interestingly enough, I didn't know that CGP Grey's face is actually available online. You can just Google CGP Grey face and you can literally find it. And he still tries to sort of hide it, but I mean, it was leaked so many times. So I don't know. By the way, he looks exactly like his avatar. Or is it not him? Maybe it's not him actually. But I'm pretty sure his face is not like a secret. Yeah, it's just too fucking easy. Yeah. Okay. Maybe he's like just pretending that he's hiding his face, right? He's just pretending. So people think that he's hiding his face, but in fact he just doesn't care. I could imagine him being like that. Alright, so rotate, we have translate, and here is the most important one. We need perspective, right? We need perspective. Met4, perspective. So we're gonna put it like that. Perspective. And we're gonna just accept this entire thing here. And yeah, we'll have to swap the columns and the rest of the things, but it's not that hard to do. Alright, so we're gonna have a float 10 half 4v, tangent 4v and half of the tangent. There we go. And then we're gonna have a mat for result. What's interesting is that, do we wanna... Let's actually initialize everything with 0, just in case. I think in this case it does make sense to initialize everything with 0. And just return the result. Okay, we're returning the result. So I might as well actually copy-paste this entire thing, because then I can essentially just swap the columns and rows and it's going to be the same. Right, so another thing I will have to probably change is float literals, because in GLSL they're not starting like that. And now I can just do something like this, a boom, and everything seems to be working. I just had across the idea, math-focused programming language like MATLAB, but the notation is later. Isn't it like literal programming, is it not? Yeah. Combination of later and excuse me, and the programming language. Have you looked into literal Haskell, by the way? Well, I mean, it depends on what exactly you mean. I'm not sure what exactly you mean. Literal Haskell. Literate programming. So essentially, you start your file with LHS, right? LHS file. So, and you write like in LaTeX. I think I can probably open it like that. So main.lhs, right? And here's an interesting thing. So you are in elite Haskell now. You're elite Haskeller. So essentially, I think you can write LaTeX now, but within specific code blocks, right? You can have like a chapter. I forgot how to do things, right? So here's the thing, and then inside of the code you can write Haskell. So here's the interesting thing. You can take this file and feed it into PDF later, right? And it will turn this into a PDF file. But then you can take this same file and put it into JHC, and it will compile it as a program. I'm not fucking joking. We can actually test it out, test it right now if you want to. I think it's kind of interesting. All right, so let's put some sort of hello world in here. So it's going to be like this, and put strlen hello world. I forgot how you LaTeX templates. So you start with a document and stuff like that. Let's put it this way: quick start, because I can never remember. Like org mod files with code blocks. Yeah, essentially. Preamble, yes, preamble of the document. Yeah, this is what we need. We need this thing. Let's put it here. It's gonna be article, title, author. Is there an example that I can just quick paste? Okay, so this is gonna be the first document. Date February, and then we're gonna begin the document like this. Oh my god, I cannot quick paste shit. All right, and then I can take the block and put it here. So I'm pretty sure, I'm not sure if I have to add the module there, but we'll see. So lit Haskell, I'm gonna create a folder lit Haskell, and I'm gonna move everything there. So if I try to call PDF LaTeX on that thing, I'm pretty sure it will kind of work, but it doesn't know about the code. So you need to define the code first, otherwise it's not gonna work. And I don't remember how to define code blocks. Okay, so LaTeX code block, code listing. It will take too much time, but the idea is also you can put it into GHC. GHC. And it will take some time. And compile it. Well, Haskell. I mean, it needs to warm up a little bit, but yeah. And it's also created the executable. Yeah, you got the idea. So essentially, you have a single file for both like a LaTeX PDF and for Haskell code. I guess it's actually not that difficult to parse. Essentially, you ignore everything until you encounter begin code, then you treat everything as a code, and then you ignore everything else. It's actually, you don't really need to parse the whole LaTeX, I think, to work with it properly. So it basically kind of inverses it, so it treats everything outside of code blocks as comments. So yeah, there is this thing, but you need to make LaTeX recognize the code blocks. You need to make it recognize. So maybe you need to install some package that can do that, or define a custom block, but I do not remember how to do that. So, and diving into that is going to be too much effort, but you get the idea. So it's LHS, it's called literate programming in Haskell. You can Google it up and stuff like that. So yeah, essentially that's what you can do. Yeah, let's go back to the thing. Yeah, you can probably do it like that, but I'm already over it. Thank you so much for the code. But yeah, I was just explaining the general idea. Oh yeah, oh my god. Yeah, I already deleted everything. Sorry. Well, I still have it in my buffer, but I don't want to recover it. Sorry. So right now the focus is on something else. So we have a perspective, right? So we have a perspective, and let me see What we're gonna do in here? So we accept some sort of a mesh in here, right? We accept some sort of a mesh. Let me see, in the I think it's gonna be in the main.c. In the main.c, here's the vertex position, and we do mat translate. I guess we're not gonna apply this thing anymore, and let me see what's gonna happen. So here's the I see buys. I think it's not gonna be super convenient for me, so I'm gonna actually invert it back to here because I need to see like the full picture, unfortunately. I'm not sure how full is it gonna be, but it's gonna be like somewhat full, right? All right, so now we should be able to try to translate the thing. So I'm gonna take this thing in here and I'm gonna put it here. So and it didn't compile. Nice. Let me see why. Might translate operand to arithmetic. Ah, shit. It has to be vec3. Yeah, you have to turn it into vec3. And yeah, so it actually adjusted it appropriately. So maybe we can put mat4 into m in here, right? So it's gonna be mat4, and we're gonna put it like this. Boom. And at any point, I can actually put an identity matrix here. Right, and it's just, you know, so this entire translation just adjusts everything accordingly. It just adjusts everything accordingly. So let's see what we have here. All right, so the next step that we do here, we do rotation based on the time. So right now, I think we have only the rotation around y, so that's exactly what I'm going to use here. So rotation around y, and we use time as the angle of rotation, there we go. And it doesn't compile because why doesn't compile? So no function rotate z up. I should have used y, I'm sorry. Okay, so it does rotate now, so that's exactly what I wanted. Next thing is we do the scale. Right, we do the scale and it will blow it up to 25 by 25 by 25. Yep. So we'll have to do it like that. Is it gonna work? Of course it doesn't work because why? Uninitialized. Oh yeah, vector 3. Oh my god. Okay, every time I copy paste something from C, it's not gonna work. Okay, so we cannot see it because it's too big. Gotcha. So the next thing we need to do, we need to translate it a little bit further away from us, and we'll still won't be able to see it. And let's not forget to put a vec3 in here. There we go. Still can see it, but at least it compiles. And now comes the perspective. What we're gonna have in here as a perspective? That's gonna be an interesting question. We're gonna multiply it. So 4v is gonna be 90 degrees. So let's actually remove that. So this is my pi. Does JLSL have a pi? JLSL pi. I'm pretty sure like GPUs who should have predefined constants or something. Does anyone know? Do you have pi in JLSL? JLSL pi. Radiance 80. Well, in that case, I can just do radiance 90 because that's exactly what I'm doing here. So in that case, I don't need pi. Okay, if I can just do that. Aspect ratio. I have to pass it. Wait, I think I do have a resolution, don't I? Do I pass a resolution there? I should actually pass a resolution. All right. So in main C, so when I do locations, location, I only have a time location. Okay, so let's actually pass a resolution as a uniform in here. Uniform vec4 resolution. So that's what we're gonna have here. Global, and we're gonna put something like gl int resolution location. There we go. So when we reload the shaders, after we successfully reloaded them, we're gonna do resolution. There we go. And if program, yeah, here it is. Program not failed. We set up the resolution, so it's gonna be gl uniform 2f resolution location. It's gonna be screen width and screen height. I think that's how we do that, right? So we're gonna set the resolution and we're gonna pass it to the vertex shader so it can use for aspect ratio and stuff like that. But that will mean that we'll have to recompile everything because we made changes on the CPU. And let's see if it's gonna compile or not. Seems to be compiling, cannot complain. Okay, and it's not compiling anymore because arithmetic operations, something, aspect undeclared. Oh, okay, so I fucked it up. Aspect. Alright, so we have to define it then. Aspect resolution. You use vec4 in shader. Oh shit! Thank you so much. So resolution x divided by resolution y, so that's our aspect ratio. Okay, so that should probably work. It worked. Okay, that's pretty cool. I guess I can remove. Yeah, I could have just do that on GPU. That's actually pretty great. So all of the transformations are done on GPU now. Yeah. And you know what's cool? Holy shit. Holy fuck. Plus, I can now do this kind of shit. Yes. Fuck yeah. So we can animate the field of view based on the time with the sign and shit. Holy fuck. That's cool. Look at that. So it just animates the field of view or something. Ooh. You can also animate the size, I guess. Yeah, you can basically animate all of this shit. Now you can do that on the GPU. Might as well actually keep it like that. I think it's pretty cool. I think it is in fact pretty cool. But we need to still port some of the rotation metrics, like rotate Z, right? Because I want to be able to rotate also in different directions and whatnot. So let's implement mat4 rotate Z float angle, right? So this is going to be that. Oh boy, oh boy. Where is the rotate Z? So, probably have to make it a little bit smaller. Maybe I want to split it like that. And there's something weird going on down at the screen. Okay, so the result is going to be 0. Yeah, it's going to be mat4 1, right? So rotate Z. Okay, so and we return this entire thing, so it's going to be results. Result. So this is a 0 column. It's like a pilot webcam, but better. Yeah, exactly. 0 is going to be cosine angle, right? And the next one is sine angle. Okay. So result column 1, but row 0 minus sine angle. And this one is cosine angle. There we go. So now we have that shit. And it didn't compile. I don't want to look at the error. What's the error? I don't understand. What's the error? What's the error? Value result is undeclared. Oh yeah, I forgot to do that. I'm sorry. Mat for yeah, now it works. Cool. So now I can just multiply mat for rotate z time, and now it will be rotating in several directions. So that's pretty cool. It's not even clipping that much. I really want to be able to like hot reload textures as well. That would be cool. But I don't really know how to do that. It will be also kind of interesting to generate the mesh in the vertex shader as well. But I'm not sure how to do that, but yeah. And it can stop. It stopped at the right moment. I think it's fucking perfect. Yeah. Oh yeah, I don't have a mesh shaders unfortunately, so that looks so cool. Goddamn, I feel like a professional 3D game developer. So I can turn this into like a 3D engine already. Holy shit! Probably. I don't know. Maybe I can. So 3D game when? That is so cool. Anyways. Alright, so I kind of want to organize all of that shit. I see only 2 sites. Cool. Do you need to see more? Alrighty. What do I want to do? I wanted to turn this into an array. Notice you're like 50% of the way to the 3D renderer already. Yeah. Probably should just continue. When VR? Well, I cannot afford VR, unfortunately. Maybe fortunately, it depends. So... Arrays. GLSL array. Okay, the arrays are as scuffed as in C, I suppose. Right. Can I have like variable length array? Not legal. Legal. Okay. Alright. So let's give it a try. Can I define something like matrices and say it's an array? And say that it's an empty array. Is that a thing I can do? No, of course. It would be too goddamn fucking easy. Or maybe I have to do it like that, right? Yeah, so what do we have here? Uninitialized array are not allowed in GLSL. Okay. So, but how do you initialize them though? Oh, you do it like that. Okay. So, can I do it like this? It's gonna be mat for and okay, so what does it complain about now? Unexpected. So you have to put something there. Okay, let's actually try to put like mat for 1. Will that work? And it doesn't seem to be working. Syntax error expected. Oh yeah, I see. I'm sorry. It's actually not curly braces. It's this. Yeah, boy. So the idea is that I want to put all of these transformations there. So let me quickly do that. Yeah, boy. What is this, 2017? Why the fuck would I do that? Alright, so these are separated, I guess. And let's just put it like this. Here we go. Look at that. Epic Emaxer. So now we have a shit ton of matrices. Cool. And it doesn't compile. Let's find out why. So what do we want? No matching function call. Oh, it doesn't. Ah, I see what you mean. I see what you mean. Can I move these things up there? For loops and shaders. I mean, it's all of one, is it not? Can it optimize? Like, we know the amount of iterations for the loop. Can it optimize that loop and unroll it? If it can optimize out uniforms, it should be able to unroll the loops. That's my logic, but I could be wrong. Imagine actually optimizing out uniforms but not unrolling the loops, for which you know precisely the amount of iterations at compile time. I wouldn't be surprised. Like, I've saw a lot of shit from OpenGL. I wouldn't be surprised if they don't do that. Anyways. It depends on the OpenGL driver, actually. I see. Some may do it, some may not. It's a little bit sad gear, not gonna lie. One thing we can probably try to do is... yeah, you know what? I'm gonna risk it for the biscuit. Let's put it this way. We're gonna go select everything in here. I'm gonna query replace the regular expression, comma, and I want to replace this thing with just space, star, and boom, 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 boom. It's pretty much the same. You see, there's not much difference between the array definition and this thing. I mean, yeah, it's true, but it enables us with pretty cool stuff, so we can swap them around and whatnot. So the only difference is that instead of commas, you use asterisks, and yeah. So let's just use it like that. Will it compile? It does compile. Look at that. If I forgot this thing, it will not compile. Yeah, so let's just keep it like that. I think it's way better, and it gives us the convenience of the array of matrices, and guarantees that it's not gonna, you know, have a loop that is not unrolled, right? Because we don't have a loop. So yeah, it's pretty cool. Might as well actually make it even cooler. And just do it like that, where we would... Oh shit, you know, it's gonna be even better. You know why? Because that way you can swap around the lines without worrying that if you swap the last line, you need to not forget to add the asterisk, because you never need to swap the last line. Holy shit, this is a divine intellect, I'm telling you. So now I can swap whatever transformation as I want, and it's just gonna be convenient. Holy fuck, this is so cool. This is literally divine intellect, I'm not gonna lie. Anyways. Also, let's do training white spaces. So everything looks okay. And the last thing I want to do, I want to remove the code on the CPU that is related to modifications and whatnot. So this is not needed. This is not needed anymore. We don't have to do that on the CPU, and we don't even have to pass the matrix anymore. Right, we literally don't have to do that. So here's the matrix location. I can remove that. And in the vertex, I don't even have to accept it. I can just ignore it altogether, and it still works because we do all of the work on the GPU. The only thing we do send to the GPU is the mesh. We just send the static draw mesh once, and we just keep sending the time and the resolution. Right, so, and everything else is done in the GPU. That's pretty cool. I really like that. I really like that everything is done in GPU. Okay, so let's try to recompile this entire stuff and see how it goes. Oh shit, yeah. So matrix location, we didn't have to do that. And yep, I guess that's it. We moved everything to the GPU. I really like this. And it's actually not moving the z-axis. We're not animating the position. We're literally only animating the field of view, the vertical field of view. So that's pretty cool. And let's do a committee. And then push. All right. Move all of the scene transformations to the GPU. And let's push that right into the repo. You can find the source code here on the GitHub if you are interested, of course. I'm learning a lot of shit, actually. Oh shit, what am I doing? I'm learning a lot of shite. So, what was the idea? So, since I moved everything to the GPU, right? The next step is going to be introducing the fog, right? The next step is going to be introducing the fog. I think we can utilize the z-axis for the fog, but I'm not 100% sure. Let's find out. I'm going to run this thing. Let's split everything. This is not how I want you to split that. This is how we're going to split that. Maybe I'm going to even do it like that. So let's go to the fragment shader, and so we can still use the colors, I'm pretty sure. Let's try the colors, and here are the colors that we sent along with the mesh, right? So these are just testing colors, nothing particularly special. So now what I want to do, I want to try to get the GL frag coordinate Z and see if we can use it for the fog. So I'm gonna just construct a new color out of it. So we're gonna use D as the red component. And okay, so as you can see, Z is the same like literally everywhere. Oh, I see what you mean. Z is too goddamn big. It is too goddamn big. It's probably between, I'm gonna tell you what it is. It's probably between 1 and 100. It depends on the far thing. So here's the vertex. Yeah, and what do we set for the far? We set far as 500. So essentially, for Z to make any sense for the fog, we have to divide it by 500, and it doesn't do anything. Just sin Z? Maybe. So yeah, let me see. Maybe it will also give us something. That's a good trick. So basically to see if it actually varies. Yeah, I think Z is the same everywhere. I think Z is the same. Doesn't really change much. What about W? I think we can try to use W. And I'm pretty sure W. Yeah, W could be used. We can multiply it like by 2 to enhance it slightly. Yeah, we can use W, I suppose. W is like... it's a 1 over W, and... yeah, you can kind of use it for the fog, I suppose. Minecraft... yeah, it's a Minecraft redstone. That's what it is. Alright, let's go back in here, and here it is, and then we can try to use W. I remember that we used that trick already in the RayLib thingy. Yeah, we used it already in the RayLib thingy. But what is it equal to? That's a good question at this particular point. 1 over that stuff. Oh shit, that's cool. That is scary and cool at the same time. Oh, I see what we do here. So this is the black color, and yeah, I see. So we're just interpolating between black and that color. Yeah, I don't know how to do a fog effect right away, so I can probably check out my other game that we did. So I was using RayLib. I wasn't using like a bare OpenGL as like here. But the idea was pretty much the same. So it was yeah, we did a minimum between this thing and 1, so it doesn't overflow and whatnot. Alright, so it could be minimum between that and 1, and it probably doesn't affect much. We can try to move the thing away slightly. So let's actually make it like 40. Or maybe we can try to animate specifically the position instead of the field of view. Okay, so we're animating the position, but since it's so small, you cannot see shit. So let's actually animate it with like 20. I think animating it with 20 would be okay. So it not bad at all. All right, so we can, especially when it goes inside of this. All right, so what if it's gonna be like 30? Yeah. Okay, so that was dumb. So that means that's not how you do the fog. So how would I imagine doing a fog? So I would just use the z-axis of the fragment as basically an indication, right? I would use the z-axis as the interpolator, but it's not really clear how to do that. So yeah. Maybe I just need to Google up how to do the fog effect, just to have some ideas. Alrighty. What's up, everyone? Welcome back. How are you doing? We are cooking. Can I actually put like, yep, as a texture? Let me see. So we can now do different textures. Duplicate. Oh, yep, PNG. Okay. Poke PNG, and we're gonna have a yep PNG. Yep. Cool. I can only imagine, like, how does it look like in the thumbnail when you look at the science and technology section. Fuck. I especially like these artifacts at the edges. It's just my favorite because it doesn't handle transparency properly. Do we even have a blend function for the transparency? I didn't think so. Yeah. Blend. Yeah, we don't have a blend function for the transparency. Fuck. So I didn't go back. Where? So, how do you enable blend function? Let me see. So maybe I have that in the OpenGL. OpenGL section. A template. I mean, not section. What the fuck am I talking about? Blend. All right. So, okay. OpenGL enable. I already googled that shit. Oh my fuck. I keep googling the same shit over and over again. GL enable GL blend. Yes, so this is first thing we need to enable, right? So this is gonna be the first thing we need to enable. I'm pretty sure. That's pretty cool. GL enable. Yeah, so we only have these things, and let's enable another thing, GL enable blend. And what function do we have to enable? Does anyone remember, like, something? I think it's 1 minus src alpha blah blah blah, if I remember correctly. If I do in fact remember correctly. Okay, so let's try to recompile this thing, and will that work? It kind of does. It got rid of the artifacts. If you notice it. Yeah, so there's no artifacts anymore. And you can see the the sides behind. Yeah, we actually handle transparency. Would you look at that? That's cool. Yeah, that's very cool. I like it. yeah, that's pretty cool. I like it. Only half of them are transparent. Half of them are transparent. Maybe something with normals, and how normals affect that? We don't even have any normals. That's the thing. We don't have normals at all. All right. We don't even handle normals in any way. Let me do a committee. So here's this thing. Yep. All right. All right. Let's Google up how to do fog. Как сось писать? Okay. GLSL. Fragment shader fog. Brent, did you make an emote out of that or something like that? Brand new emote. It's like a yep vortex or something. I don't know how to even call that. Yep vortex. How to implement a ground fog? What is a ground fog? GLSF for fog imitation. Victoria Rudakova, key comrade. Yep. All right, let's read the article from a comrade. The provided code snippet demonstrates the basic idea behind the fog imitation. The chosen fog model is a linear function, which means the fog factor increases linear with the distance from the current camera view. Yeah, that's exactly what I wanted, with the current camera view, but how do you keep track of the camera view? That's the interesting thing. The fog effect is added through the fragment shader. That makes sense. The GLSL shaders are provided, by the way, I'm reading an article, I probably have to credit it. Here we go, so this is what we're reading right now. Are provided together with the OpenScene Graph basic code. What is this? I don't know anything about OpenScene graphics or anything, like I just use an OpenGL code, OpenGL thing. The shaders can be used with any other OpenGL based code provided the necessary uniforms are passed to the shader. Oh, okay. So that makes sense. Simple scene. Okay, so for the scene we'll add 2 polygons located in 2 different 3D planes. We'll make them adjacent one to another so that the test occlusion colors. Yeah, okay. So we also provide different colors for each of the vertices and make sure the color binding is set to bind per vertex. Okay, that makes sense. Necessary uniform. Just like with one of the previous shaders, for drawing lines in 3D, we'll need model view projection matrix in order to obtain GL position. I use an OpenGL graph, we frame the matrix as callback, which is updated when the current camera. Okay. Well, I mean, we generate all of the matrices within the vertex shader. Like, we don't even do anything on CPU at all. Like, all of the transformations are done within the vertex shader completely. So I guess we don't need anything here. And it works, by the way. So yeah. Way too yep, yes. Modern OpenGL doesn't even have a fog. Is it supposed to have a fog? I thought it's just, you know, like a tool that you adapt for whatever you want. So it just gives you the access to the hardware on which you can run your computations and whatnot. I think that's what the OpenGL is trying to become. I think that's what it's trying to become. Okay. All right. So GL fog. I think it must be something very deprecated. I'm pretty sure. Yeah, it's a GL 2.0. Like it's kind of funny how OpenGL started with a lot of useful functions, and then they just deprecated all of them. And they said, code everything yourself. Right. So we give you shaders, implement all of that shit yourself. And we deprecated all the useful functions. Yeah, so it's available up until OpenGL 3, and yeah, so all of that shit is deprecated. All Alright, so let's continue reading. Another variable we'll need is the camera position in 3D space at any time. Once again, we use OpenGL callback system to extract camera eye and pass it as a uniform. We do have a position. Well, we know for a fact that the position of the camera is 0, 0, 0. So, yeah. Another, okay. Both uniforms are added to the state set variables of the root scene. Okay. GLSL shader. Okay. For our purpose, we will only need to use vertex and fragment shaders. No mesh shaders? Disgusting. The vertex shader sets up the correct GL position, and the fragment shader is where we'll introduce color changes in order to imitate foggy environment. Ooh, I kind of see what it means. All right. Okay, so here are the colors, but we're just passing colors. We're just passing colors, and we're passing the vertex, like transform vertex. As an output, we make sure to pass color and 3D coordinates of each way. The latter will be used when we'll be calculating the distance between the camera. Okay, the fragment shader. All right. So we're gonna pass the fog color. We derive the fog color as a mix between the passed color of the geometry and the background color. Okay. In the fragment shader, we also have to pass a fog color as a uniform. I don't think it's that necessary. Now we can calculate the fog color based on the fragment location in 3D space. First, we calculate the Euclidean distance E between the camera I and a 3D vertex V. Cool. This is not a GLSL, by the way. Okay. We use the distance and plug it into our linear function for fog get alpha coefficient. Alpha coefficient will then be used in GLSL mix alpha. Okay, cool. We derive alpha by f max minus distance. Max and mean, where a minimum and maximum distances in which. So f min and f max are essentially like far and near and far clipping planes in the camera. So beyond the minimum distance, the geometry of this part will totally visible, while beyond the maximum distance, the geometry will not be visible anymore. So for simplicity, we set up the fog thresholds inside the fragment shaders, but they can also be passed as uniforms. The simplest for the fragment shader is thus. So, alright, the camera eye, so it's a position, it's a uniform, okay. Okay, I guess that's what we need here. That's what we need here. So we get the vertex, right? This is the fragment shader, right? And we also pass the vertex. Oh, wait a second. Oh shit. Oh, I see. I missed the like a very important point. Okay. So yeah, I didn't think about that. You can pass vertices to the fragment shader just like that, and it will interpolate them for you. Oh shit, that's actually okay, that makes sense. So first we assign the position, which will in turn start generating fragments and then interpolating fragments. But we can put the untransformed vertex and it will just interpolate it for us, so we can use it for different. Okay, this is actually super cool. Thank you so much, Victoria Rutkova. I really appreciate it. So that's the basic point that I needed. I don't really need anything else. I just needed this line to realize how to implement the fog effect. Like, I just didn't realize that I can actually do that. So yeah, okay, comrades. Okay, comrades helping each other. That's nice. All right. So I think I want to make a small break because I need to pee. Alrighty. SB. I think it's gonna be 2 minutes. I think it's gonna be 2 minutes. All right. So, and I'm also gonna put the followers mod for 1 hour. All right. Just in case. All right. Let's make a small break. You guys have fun. Yo, I'm back. Champion of the arena. How's it going, everyone? Welcome back. Okay, so let's try to. So the music is too loud, I think. Let's try to implement that. So we pass the vertex, right? Pass the vertex, and then we take the vertex. We find the distance between the camera. We know the camera position is hard-coded, so nothing special there. And then we get the fog factor. So we have that. This is pretty straightforward, and yeah, that's cool. All right, so let's try to code that. Maybe I'm gonna code all of that at runtime while the application is running, because I don't plan to add any modifications to the CPU code. That's fucking scary. Maybe I'm gonna change to a different one, so it's not gonna be yep. It's gonna be pog. Let's go back to pog. Let's go back to pog. Back to bog. So here we have that. So we have my little fog in a fragment shader. A Woo cube. So to, like, you mean animated textures? Well, I can do that without animated texture quite easily, but alright, so let's put it like that. But animating it, basically I'll have to probably create separate textures for each individual frame and animate them on CPU or something like that. So that sounds like the way to go. But yeah, a sprite sheet could be also sprite sheet, but you have to deal with the bleeding, texture bleeding and stuff like that. I don't know how to deal with texture bleeding. So now it's gonna be main vert. Main vert, and we're going to have an output here. So this is going to be UV. So here's UV color, and we're also going to have a vertex, right? So here's the vertex. Just replace original texture in memory on CPU. I'm already outside of the context, I'm sorry. So here's the vertex, and vertex position, right? So vertex position, if I try to reload it, it doesn't really break per se, but we don't accept the vertex yet. We need to accept it somewhere here, like for vertex. There we go. So this is the information that we accept from the fragment shader. So what if I try to do something like this? It doesn't really complain. That's really strange. So if I try to do something like that, well, it does break. Yeah. Okay. So we have that. So after that, I need to compute the distance. Since the camera is located at 0, 0, 0, the distance is literally equal to v. We don't have to do that step at all. So, well, I mean, the distance is going to be the length of vertex, right? So this is the length of vertex, which we can then use for the fog stuff. We can use it for the fog stuff. So we probably have to define like a fog max, define fog minimum. So we have the clipping planes from 1 to 100, right? So let's define something like a min is going to be 1 as well, right? But the max is going to be something like 50, right? Yeah, since we're moving like between like 0, 30, 40, like 50 is going to be the max one. 50 is going to be the max one. So, well, I mean, I guess that makes sense. Fog factor. Fog factor. It's going to be float. Fog factor, and this is going to be the distance. Yep, this is going to be the distance. If the distance, well, that's an interesting way of doing that. Well, if it's greater than, if it's less than or equal fog minimum, we instantly return 0. And then if it's greater or equal than max, we instantly return 1, otherwise we're interpolating it. So, so essentially we find the distance from fog max to the distance, right, and we invert it as far as I can tell, right? So we're inverting it, and then we just divide it by the distance between fog max and fog min. Yeah, it's actually pretty simple interpolation. Okay, this is actually a very simple interpolation. I could have come up with that myself if I had an idea of passing the current vertex to the shader, to the fragment shader. Right, so after that, we literally can do fog factor length, and we can use this as an interpolator between the texture color and the fog color. Fog color. Okay. So it's going to be mix between that thing and something like, let's say, vector 4, 0, 0, 0, 0, 1, right? So this is going to be black, and the factor is this thing. So pretty straightforward in my humble opinion. Yep, so here are the things, right? So we're interpolating from texture to black color, and this is the factor of interpolation. And that is very interesting, in fact. It's doing something. It's definitely doing something. So maybe I don't have to invert it in this particular case. What if I don't invert it? It kind of requires being inverted. All right. So so the distance is literally the fragment. Okay. Well, it works in her example, but not in mine. I think I'm doing something dumb. You're not actually moving the mesh, so the... No, I do actually move the mesh. That's the thing. So I already changed that. I already changed the behavior. So I'm not animating field of view anymore. I'm actually animating the position of the mesh. But wait, fuck, I see. No. The vertex stays the same. I pass the vertex before transformation. You're right. You're right. So we have to do that slightly differently. So I need a version. I need to pass something before perspective transformation. That's what we need to do. One should be outside of the parentheses. What? Oh shit. Oh shit. Fuck. Oh, okay. So that's already something. But it doesn't really help much. So if I make it like this. Yeah. It still doesn't help much because we're actually using not transformed thing. So we need to apply all of this transformation to the vertex here, but not the perspective. Yes, that's what we need to do. All right. So might as well actually save that. Yeah, here's the the difference between the camera matrix and not camera matrix, view matrix, or whatever people call it. Yeah. So this is sort of like a view camera or something, without the perspective transformation, and it doesn't compile. Why doesn't it compile, by the way? We're just reinventing the model view projection matrices, I think so. So it's 89. Oh, I forgot the semicolon. Oh shit, fuck. It worked. Fuck, it actually worked. It actually scared me a little bit. Here's the fog. Actual fog. Holy shit, that's so cool. Jump scare. Fog scare. Yes. Fog. All right, so let's try to do the following thing. Now I know how to do that. Now I know. Let's actually put 50 here, so it's a little bit better. Holy shit, that's so cool. Yeah, I know how to do fog now. Fog. Thank you. Thank you so much, Victoria Rudakova, for this beautiful, beautiful article. Check out this article. It actually helped me. So yeah, now I know how to do fog. Fog. Cool. This shit is kind of addictive to me, I'm not gonna lie. It's like once you wrap your head around it, like you want more, you want to build more and more complex scenes and like more complex effects. It's really goddamn fucking addictive. Just thinking, just trying to push the limits of this kind of thing. Alrighty. So, and now you want to make a yeah, now I want to make a 3D game engine. Holy shit. Fuck. Ambient occlusion when? We'll see. I didn't even know what is ambient occlusion, so I'll have to learn it first. I did heard about ambient occlusion on John Blow's stream, but I don't know what it is. Alright, so yeah. Implement fog. And let's push that right into the repo. And oh shit, I forgot to say that yes, we did in fact implement fog. So yeah, generate cube mesh, render the cube mesh with a perspective projection, texture the cube, fog, simple lighting, the classical one with normals and stuff. Another interesting challenge would be like literally generate a mesh on the vertex shader. But how to do that? Like we already tried to do that a long time ago with like strip. Triangle strips and whatnot, but yeah. Simple lighting. For the simple lighting, we'll need normals. We need to generate normals. In short, ambient occlusion darken. Yeah, I kind of googled it up, like ambient occlusion. Let me see. So the Wikipedia kind of describes it well enough. It's like a 3D graphics model animation ambient occlusion is a shading and rendering technique used to calculate how exposed each point in the scene is to ambient light. So it has something to do with ambient light. I guess I think you might need geometry shaders and or mesh shaders to make vertices on the GPU. Like yeah, I see what you mean. Like I see that you mean in a non-kappa way. But we can do that trick with the GL vertex instance or GL vertex ID, right? So basically, based on the ID of the vertex, generate the corresponding strip or something. Yeah. But I'm not sure how easy would that be. The simplest lighting is Fong, Blink Fong, right? I don't even know what it is. I don't know what that means. I'm not a computer graphics engineer or programmer or whatnot. But one thing I know is that if you have triangles and you have normals in the triangles, right? If you have normals associated with each triangle, right? You can use those normals to calculate the angle between your camera, right? Or maybe between the light source and this normal. And that angle will tell you how much you have to make the pixel brighter or darker. And that makes sense. I don't know what bling fong bing bong means. What is that? I don't understand. I'm sorry. Like I don't know these words. I'm a very stupid person. Like I have a normal, I have the other vector, I just compare them and it gives me the thing. So why do we need anything else? Like, yeah, it's actually a pretty simple concept, but probably difficult to implement. Is that what it's called, like a fong, blin fong thingy? All right. I'm a little bit tired already. Ooh, you know what? I think I'm gonna... Yeah, I think I'm gonna implement that later because I'm already tired. because I just learned a bunch of completely new concepts and my brain is fucking melting. And my brain has been melting for the past 3 days because I've been working on that like for 3 days straight. And ooh, am I tired? I think I am tired. So OpenGL is really tiring. So yeah, I think I'm gonna call it a day. You can find the source code that we developed on the stream here. If you're interested, you can just grab this source code in here if you want to and run it on your machine and see if it works for you. Maybe modify it. It's under MIT. You can do whatever the fuck you want with it. Yeah, so check out our schedule page for more information on different projects we're working on. Check out our VODs channels, a channel where we upload the recordings of the streams. And check out our Discord server for offline discussion with the community. And let's maybe rate somebody. How about that? Let's maybe rate somebody. Who can we rate? Is anyone doing any 3D graphics right now on the Twitch Science and Technology section? The topic that I chose for the Friday stream was really hard. I was triggered so many times by stupidity of OpenGL API, but the thing at the end, it was worth it. I learned a lot of cool things. So Bailada is streaming, so maybe we should rate Bailada. But he bans sweeps. Don't act like you didn't know that, okay? So you very well knew that. Okay. So let me see. Let's actually rate Bailada. So raid Bailada. Okay. Get ready for the raid, boys and girls. Get ready for the raid, and I see you all tomorrow. Love you all.